Okay, think about your phone for a second. Or your headphones. Maybe even that electric car you're eyeing up or already driving. Ever wonder what's really inside doing some of the critical work? Well, often it's these incredibly powerful magnets. And not just any magnets, we're talking rare earth magnets. And right now, based on the recent news about rare earth magnets and their EV role, they're really at the center of this uh, quiet but intense global struggle. Welcome to the deep dive. Today, we're really getting into this critical material, our mission, to understand why these magnets are so vital, how one country basically cornered the market, what recent strategic moves mean, and crucially, what this implies for the global electric vehicle market. It's kind of a look into a hidden monopoly, a geopolitical tug of war playing out.
It really is. And it's, a perfect example of how materials you might not think about twice actually underpin so much of our modern tech. If you understand the supply chain, you get a direct view into some major geopolitical and economic shifts happening as we speak.
Okay, let's unpack that. First things first. What are rare earth magnets? Because the name itself, rare earth, sounds, well, rare. But is that right?
It's a bit of a misnomer, actually. Geologically speaking, the elements themselves aren't super scarce in the Earth's crust. Finding them concentrated enough to mine economically, that's one challenge. But the real difficulty, the bottleneck, is the processing. Separating these elements from each other is incredibly complex, energy intensive. It involves tricky chemical processes like solvent extraction, and importantly, it creates significant environmental challenges.
Right, and that environmental cost, that played a big role historically, didn't it, in terms of who developed the processing capacity?
Exactly. Dealing with the waste, sometimes radioactive byproducts, the toxic chemicals, it's expensive and requires strict controls. For a long time, many Western nations, while maybe doing some mining, shied away from really investing heavily in the large-scale processing because of those environmental regulations and costs. That created a vacuum, and China deliberately stepped in to fill it.
Got it. So they're hard to get out and process cleanly, but once you have them processed, what makes the magnets made from them so special, so powerful?
It boils down to their sheer magnetic strength. They are, by far, the strongest type of permanent magnet available. We measure this with something called the energy product, BH max. For neodymium magnets, the most common type, we're talking figures up to like 512 kilojoules per cubic meter. That's just world stronger than older types like ferrite magnets. It means you can make components much smaller and lighter while getting more power.
Incredible strength, small package, makes sense. Anything else unique about them?
Yes, their resistance to being demagnetized, what we call coercivity. They hold on to their magnetic field very strongly, even in tough conditions or when facing opposing fields. That's critical for reliability, especially in things like electric motors. There are two main types, as you mentioned, neodymium, NdFeB, and then samarium cobalt, SmCo. Neodymium is generally stronger at normal temperatures, but samarium cobalt is the star for high temperature. Uses it stays stable up to around 300, 350 degrees Celsius, that's over 500 Fahrenheit.
Okay, and this directly connects to the electric vehicle story, doesn't it? Why are these magnets so absolutely fundamental for EVs?
They are the heart of the most common type of high-performance EV motor used today, the permanent magnet synchronous motor, or PMSM. That amazing strength we talked about. It lets car makers design motors that deliver really high torque. That instant acceleration EVs are known for, but in a package that's compact and lightweight.
Which is obviously huge for designing the whole car and how it performs.
Absolutely huge. Lighter, smaller motors mean less overall vehicle weight, which helps with efficiency. But the biggest deal is probably the energy conversion. These PMSMs can convert over 90% of the electrical energy from the battery into mechanical power. That level of efficiency is just vital for maximizing driving range. And range is, still a top concern for anyone buying an EV. So automakers competing on performance and range, they're pretty much locked into using these magnets. It's like a performance dependency trap.
And getting that top-tier performance, especially under demanding conditions, sometimes requires specific flavors of these rare earths, right?
Yeah. You've hit on a really key point there. To keep neodymium magnets working well at higher temperatures, like inside a hard-working motor, you often need to add small amounts of heavy rare earth elements, like dysprosium and terbium. And the thing is, the processing for these heavy rare earths, it's even more concentrated globally than for the light ones. So that adds another layer of cost and significant supply risk directly tied to getting that high-end performance.
Okay, so it's crucial for the main motor, but they're used elsewhere in the EV too, aren't they? It's not just one component.
Oh, definitely not. They're scattered throughout the vehicle. A typical EV might contain somewhere between 2 and 5 kilograms, what's that, 4 to 12 pounds maybe, of rare earth magnets in total. You find them in the electric power steering, regenerative braking systems, the air conditioning compressor, various cooling fans, battery management components, tons of sensors. It means the shortage doesn't just impact whether the car moves, it can affect all sorts of other functions too.
Wow, okay. That really paints a picture of how indispensable they are. Which brings us squarely to the geopolitical side, China's dominance. How did one country end up controlling so much of this market?
Well, like we touched on, it wasn't accidental. It was a very conscious, long-term strategic decision by the Chinese government, going back decades. They poured resources into it, subsidies, low-cost loans, state support, and critically, they operated with environmental regulations that were, let's say, significantly less stringent than in many other parts of the world at the time. That allowed them to produce these materials and the magnets at a much lower cost base. They essentially absorbed the environmental costs that others weren't willing to.
So that willingness to handle the messy, costly processing became a massive strategic advantage.
A game-changing one, yeah. They didn't just mine. They mastered the really difficult and, frankly, polluting separation and refining technologies. Other countries might have had the raw ore or even developed some early tech, but they didn't build out the domestic industrial-scale processing capacity because of those environmental hurdles and costs. China did. They built it, they scaled it, they became the world's refinery.
And when you look at the actual market share numbers across the whole value chain, it's pretty staggering.
It really lays bare the extent of the control. China holds roughly half, maybe 49–50% of the world's known rare earth reserves. They account for maybe 60–70% of the actual mining. But the real choke point is downstream, processing and refining. They control somewhere between 85 and 92% globally. That's huge. It means even ore mined in, say, Australia or the US often ends up going to China to be refined into usable oxides or metals. And then when it comes to making the actual finished magnets, they produce about 90% of the world's supply and export around 70% of the powerful neodymium magnets.
That processing figure, over 90%, that's just a massive lever they can pull.
It absolutely is. And remember those heavy rare earths we mentioned, dysprosium, terbium, the ones needed for high-performance, high-temperature magnets? China processes virtually 100% of those, like 99 to 100%. That gives them incredibly targeted leverage over the components needed for the most critical applications. Top-end EV motors, yes, but also crucial defense systems. Trying to build a completely independent supply chain for those specific materials is extremely difficult for anyone else right now.
Which brings us to recent events. We've seen China starting to flex that muscle, haven't we, with these export curbs. It wasn't just one sudden move, was it? It's been building.
That's right. It feels like a deliberate phased strategy. It started building momentum, say, December 2024, with export controls on materials like gallium and germanium, also important for tech, and tighter checks on graphite exports. They explicitly linked these to dual-use military and civilian applications. Then, fast forward to April 2025, that's when they rolled out mandatory special export permits specifically targeting 7 heavy rare earth elements and the magnets made from them.
So hitting not just the raw materials, but the actual finished high-value magnets too.
Exactly. If you want to export the element itself, or an alloy, or a chemical compound containing it, or the finished magnet, you now need a specific government permit. And this process, well, it adds weeks, potentially months, of bureaucratic delay and uncertainty. It signals a clear shift toward controlling the valuable downstream products, not just the upstream resources.
Okay, so they introduced these permit requirements. Did it actually work? Did exports drop?
Oh, yeah. The customs data from April 2025 was pretty dramatic. China's overall rare earth sales to the U.S. fell by 37% compared to the previous year. But for rare earth magnets specifically, the drop was even steeper. Down 58% for the U.S. and 51% worldwide. Now, there was a bit of a rebound in May. Exports were up from the April low, but still way down compared to the year before. Early reports suggested only about a quarter of the hundreds of export permit applications were actually getting approved initially.
So it effectively acts like a soft ban, not outright prohibition, but using red tape to choke off supply.
That's a good way to put it. By making the export process cumbersome, unpredictable, and subject to review, they create massive friction. It disrupts supply chains, creates uncertainty for buyers, and allows China to exert control without the, perhaps, bigger political fallout of a total declared ban. It gives them flexibility to tighten or loosen the tap as they see fit.
So the big question, why now? What are the underlying geopolitical reasons for China doing this?
Fundamentally, it looks like they're using this rare earth dominance as a pretty potent bargaining chip in wider disputes. The timing and the way it's framed suggests it's a direct response, kind of a tit-for-tat move related to foreign import tariffs, particularly from the U.S., and what China perceives as efforts to curb its technological and economic rise. It makes a critical industrial supply chain hostage to political wins, not just market forces.
So it's definitely tied into the broader tech competition and trade tensions we've been seeing.
Absolutely. News reports frame these curbs as direct retaliation for things like U.S. sanctions aimed at restricting China's access to advanced semiconductors, especially for AI and military applications. It's like a precision countermove, targeting a known vulnerability of their economic rivals.
And they're using national security as a justification, too.
Yes, that's the official line. Protecting national security and interests, fulfilling global duties of nonproliferation, citing the dual military and civilian purposes of these materials. And, it's true that these heavy rare earths are vital for advanced military tech in the West, sophisticated radar, guidance systems and missiles, components in fighter jets like the F-35. So there's a strategic paradox. China uses the national security rationale to restrict exports, which in turn could potentially weaken the defense capabilities of rivals by limiting their access to essential materials while ensuring their own military has preferential access.
Beyond the geopolitics and military angles, is there also a domestic economic advantage for China in doing this?
Oh, definitely. A major one. Restricting exports tends to keep domestic prices for rare earths lower within China. That directly cuts production costs for Chinese companies making things like EV motors, wind turbines, electronics. It makes their final products potentially cheaper and more competitive on the global market. It's a boost for their own booming EV sector and strengthens their entire domestic industrial ecosystem. It's a strategic pivot, really. The goal seems to be shifting from just controlling the raw materials to dominating the whole high-value manufacturing chain that uses those materials. Plus, it could subtly encourage foreign companies who need these magnets to actually set up manufacturing inside China to guarantee access and potentially lower costs.
Okay, so this complex web of strategy, economics, and geopolitics, it all comes crashing down on the global electric vehicle market. Given that dependency we talked about, what are the really profound impacts we're seeing right now?
Well, the core issue is that performance trap. Car makers have designed their best EVs around the advantages these magnets offer: high torque, efficiency, good range. When the supply gets choked off, they face really tough choices.
And these aren't theoretical impacts anymore, are they? We're seeing real disruption.
Significant disruption, yes. We've seen reports filter out about production lines halting, plants temporarily stopping work in places like Europe. Car makers are having to slash production forecasts. There was news about one major Asian automaker cutting the production target for a new electric SUV by more than 60%, explicitly blaming magnet shortages. In some regions, like India's passenger car and two-wheeler market, inventories were reportedly projected to run dry by mid-July 2025. It really underscores how fragile things are when you rely so heavily on one source for such a critical component. It has echoes of the semiconductor shortages after COVID, doesn't it?
It does, and that kind of disruption must hit the automakers hard financially.
Hugely. They might be forced to switch back to older, less efficient, maybe bulkier motor designs just to keep lines running, which hurts the appeal of their EVs. Or they might have to decontent vehicles, remove features that use these magnets, like certain types of power seats or high-end sound systems. And any production stoppage or delay means lost sales, lost revenue, plus the added costs of managing the disruption. It's painful.
And then there's the regulatory angle. Governments in many key markets have strict EV sales targets or emission standards.
That's another critical layer of risk, yeah. If automakers physically can't build enough EVs because they can't get the magnets, they might fail to meet those government mandates. That could lead to hefty fines or penalties for noncompliance. We even heard reports that the market for the regulatory credits automakers trade based on their EV sales is basically sold out through 2027, so they can't easily just buy credits to cover a shortfall. This puts governments in a tough spot, too. Do they have to consider easing the mandates or maybe offering support to automakers caught in this crunch?
So, a real crisis unfolding. What are we seeing in terms of global responses? How are industries and governments trying to mitigate this?
Well, the crisis is definitely spurring action. There's a massive push now to diversify supply chains away from China. Countries like Australia, Canada, the U.S., they're all investing, trying to build up their own mining and, crucially, processing capabilities. In the U.S., you've got significant government funding flowing through things like the Inflation Reduction Act, the Bipartisan Infrastructure Law, Defense Department initiatives, all aimed at creating a domestic mine-to-magnet supply chain. Plus, financing support from agencies like the Exxon Bank. The EU has its own Critical Raw Materials Act. And there's international coordination too, like the Mineral Security Partnership, the MSP, trying to get allied nations investing together in secure sources.
But building these completely new non-Chinese supply chains, that's not going to be cheap or quick, is it?
It's not at all. Estimates suggest that sourcing rare earths from outside China could mean prices are about 9% higher, looking out towards 2030. That's mainly down to stricter environmental rules and higher labor and operational costs in places like North America or Europe. You could call it a strategic premium, paying more for security and resilience. It probably means the market will fragment. You'll have a higher cost, secure, maybe strategically aligned supply chain, coexisting with the potentially cheaper but politically risky Chinese supply.
Okay, so diversifying the source is one track. What about the technology itself? Is this pressure accelerating efforts to use fewer rare earths or even design motors that don't need them at all?
Absolutely. This is where the crisis is acting as a powerful catalyst for innovation. R&D into rare earth-free or rare earth-light technologies is getting a huge boost. On the materials side, people are looking hard at alternatives using abundant elements. Iron nitride is one getting a lot of buzz. Theoretically, it could be even stronger magnetically than neodymium and handle higher temperatures, though scaling up production is still a hurdle. Manganese aluminum carbide is another older idea being revisited with new techniques.
And what about designing motors that just skip the permanent magnets altogether?
Yes, that's a major focus too. Externally excited synchronous motors, or EESMs, are a leading contender. Companies like ZF have production-ready EESM systems. Their I2SM tech uses electrical induction to create the magnetic field instead of physical magnets. They claim performance comparable to rare earth motors, high torque density, plus significant benefits like lower production CO2 footprint. You also see big players like Vallejo and Moly teaming up to develop EESMs, particularly for higher-end EVs. Then there are synchronous reluctance motors. They're magnet-free, but traditionally have lower power density. And even more futuristic concepts like software-defined motors trying to use clever control algorithms to mimic permanent magnet performance without the magnets.
Sounds like the innovation engine is really firing up. What about recycling? Taking magnets from old EVs or electronics and reusing the rare earths?
Recycling is definitely part of the long-term vision. But realistically, it's not ready to solve the problem today. It's still quite limited commercially. Currently, estimates are that less than 1% of rare earths actually get recovered from end-of-life products. The collection infrastructure isn't really there, and the processes to efficiently extract the rare earths from complex products like motors are still developing. There's research into advanced methods, hydrometallurgy, bioleaching, and some corporate initiatives from big tech companies and automakers like Toyota, who worked to reduce the heavy rare earth content in some Prius motors years ago. But it's not at scale yet.
Okay, so pulling all these threads together, what's the overall outlook, especially for the EV market, and what should different players be thinking about strategically?
Well, in the immediate term, say the next year or two, expect more bumps in the road. Supply chain bottlenecks, price swings, production adjustments, inventory worries outside China. That's likely the reality. EV makers face a tough balancing act, securing the magnets they need, maybe paying that strategic premium while deciding how to manage production, maybe tweak vehicle features, and seriously evaluate alternative motor technologies for future models.
And looking further out, the longer-term picture.
The longer term looks like a fundamental shift. This whole episode is massively accelerating the global diversification effort, building those non-Chinese supply chains. And maybe even more importantly, it's pouring fuel on the fire of R&D for rare earth-free alternatives and better recycling. These things might have been seen as nice to have before. Now they feel like strategic imperatives.
Which brings us back to China's position. Does this strategy risk backfiring on them in the long run?
That's the big strategic question, isn't it? Their export controls give them undeniable short-term leverage. But the disruption and uncertainty they're causing is the single biggest incentive for the rest of the world to finally break its dependence. By pushing too hard, they might accelerate the development of alternative supply chains and, crucially, alternative technologies to the point where global demand for their specific rare earth products starts to decline significantly down the road. That could lead to overcapacity in their industry and ultimately weaken their dominance.
So it really is this race, China leveraging its current power versus the world scrambling to innovate and diversify away from that power.
Exactly. And if you think about recommendations based on what we're seeing, for governments, it's about doubling down on supporting those allied supply chains, maybe building strategic stockpiles, and funding the R&D for alternatives. For the EV manufacturers, it has to be about aggressive diversification of where they get magnets, mapping their supply chains down to the raw material level, and critically integrating R&D on magnet-free motors into their core product strategy, like yesterday. And really, for any industry that relies on these magnets, wind power, consumer electronics, aerospace, the message is similar. Understand your vulnerability, diversify, innovate.
This has been fascinating, a really deep dive into something that, operates behind the scenes for most people, but is having these huge tangible effects on global industry, on geopolitics, and on the transition to electric vehicles. We've seen just how critical these rare earth magnets are, how China achieved its dominance and is now using it, the shockwaves hitting the EV market, and that accelerating global response to diversification, innovation, the whole nine yards.
It really highlights how controlling seemingly niche materials can become a powerful tool in today's world.
Right. And maybe here's a final thought to leave you with. Is it possible that China's very move to weaponize its rare earth control, aiming to solidify its power, might ironically end up being the biggest catalyst the world needed? Could it push innovation so hard and fast that we eventually develop technologies making these specific magnets less essential, ultimately eroding the very leverage China sought to wield? It really makes you think about the unpredictable ripple effects of geopolitical chess moves in a world constantly racing forward technologically. That's all the time we have for this deep dive. Thanks for joining us. We'll be back next time to unpack another critical topic shaping our world.